A rock nearly a kilometer wide just flew past Earth, closer than it's been in over 400 years. Headlines screamed, "Near miss." Social media lost its mind. But here's what nobody's telling you. This asteroid was never the threat. Scientists tracked 1997 NC1 for almost 3 decades and knew exactly where it was heading. The thing that should actually keep you up at night is something NASA never saw coming, and it already hit us. July 5th, 1997. A telescope on the summit of Haleakala in Hawaii picks up a faint dot drifting across the sky. That dot was 1997 NC1, an Aten-class asteroid, meaning its orbit actually crosses Earth's. Estimates put it somewhere between 700 meters and a mile wide, with the best guess around 900 meters. To put that in perspective, this isn't what NASA calls a city killer. It's far bigger, the kind of object that on impact would trigger a regional to global catastrophe. The headlines screamed dangerously close, 2.5 million kilometers. Sounds terrifying until you realize that's 6.7 times the distance to the moon. Picture that gap, then multiply it almost 7 times. That's where this rock was. Scientists have tracked its exact path since 1997. Zero risk, zero surprise. So why should you care? Because the real danger was never this rock. It was something much smaller, much faster, and completely invisible. NASA didn't just watch 1997 NC1 fly by. They interrogated it. Between June 24th and 29th, the Deep Space Network aimed its massive Goldstone radar dish straight at this asteroid to nail down its exact size, shape, and rotation. And they had to, because this was a once-in-a-lifetime shot. 1997 NC1 hasn't passed this close since before the year 1600, and it won't come back like this until 2133. But what if I told you there's already been one that slipped through completely unseen? February 15th, 2013. An ordinary Friday morning in Chelyabinsk, Russia. Dash cams rolling, commuters heading to work. And then the sky tears open. A meteor screams into the atmosphere with zero warning. No alert, no satellite flag, no telescope ever spotted it. It came from the direction of the sun, the one blind spot where ground-based telescopes simply cannot look. By the time anyone saw it, it was already exploding. Here's what makes Chelyabinsk so haunting. That meteor was roughly 20 meters across, about the length of a bowling lane, and it still blew out windows across an entire city, injuring over 1,000 people. Now consider this. 1997 NC1 is roughly 50 times wider. We tracked the big one for almost 3 decades and knew its every move. The small one hit us completely blind. And NASA estimates thousands of objects in that deadly middle range, 140 meters and up, are still out there, undiscovered. NASA has a single planetary defense mandate. Find at least 90% of every near-Earth object 140 meters and larger. That's the size threshold that keeps astronomers up at night, the city killer class. Picture it, a rock roughly the height of the Statue of Liberty, hurtling through space at tens of thousands of miles per hour. One impact from something that size could flatten an entire metropolitan area. And when NASA started counting how many are actually out there, the number they found was terrifying. Of roughly 25,000 estimated near-Earth objects in that size class, about 15,000 are still completely undetected, more than half. Rocks big enough to level a city, drifting through our neighborhood right now, and we have no idea where they are. They're not hiding, we just haven't found them yet. And as you're about to see, some of them are almost impossible to find. Here's the blind spot. Ground-based telescopes can't see objects approaching from the direction of the sun. The glare whites everything out. That's not a flaw in the system. It's a law of physics. On February 15, 2013, a meteor exploded over Chelyabinsk, Russia. Not a single agency on Earth detected it before impact, because it came straight out of the sun's glare. The one place we can't look is exactly where the danger can hide. So what would we actually do if one was headed straight for us? September 26, 2022. NASA deliberately crashed a spacecraft into an asteroid at 14,000 miles per hour. Not in a movie, not in a simulation. A real spacecraft, a real asteroid, a real collision. The mission was called DART, the Double Asteroid Redirection Test. It was humanity's very first attempt to change the course of a celestial body on purpose. And what happened next proved something nobody on Earth was sure of until that very moment. The target was Dimorphos, a moonlet just 160 meters across, orbiting a larger asteroid called Didymos. Didymos itself is about 780 meters wide, nearly half a mile. NASA chose this pair for one brilliant reason. When you nudge a moon's orbit around its parent, you can measure the change from Earth. No guesswork. A perfectly designed experiment. Slam into the little one, then watch to see if its orbit shifts. And what the data showed stunned everyone. DART shortened Dimorphos's orbit by 32 minutes, from 11 hours and 55 minutes down to 11 hours and 23 minutes. Half an hour shaved off the orbit of a moon by slamming a spacecraft into it at 14,000 miles per hour. For the first time in recorded history, human beings intentionally moved a celestial body. Let that sit for a second. We reached across deep space and changed the path of a moon on purpose. But one successful punch doesn't mean we're ready for the real fight. But here's the catch, and it's a big one. Was a proof of concept, a single test. We proved a spacecraft can nudge an asteroid off course. What we don't have is another one. There is no deflector sitting on a launch pad right now, fueled and ready. If astronomers found a city killer on a collision course tomorrow, humanity's response would start with building the spacecraft that saves us from scratch. After Chelyabinsk, NASA built something new. In January 2016, they established the Planetary Defense Coordination Office, and its entire job is exactly what it sounds like. Find every threatening rock in the solar system and coordinate what to do if one's heading our way. But here's the problem they still haven't solved. Ground telescopes can't see what's lurking in the sun's glare. And the sun's glare is exactly where Chelyabinsk came from. Completely invisible until it exploded over a city. The answer is already being built. It's called NEO Surveyor, an infrared space telescope targeted for launch around 2027. It's designed to do the one thing no ground telescope can: scan the regions near the sun where dark asteroids hide in plain sight. Infrared doesn't need sunlight bouncing off a rock. It reads the heat the rock gives off on its own. For the first time, we'd have eyes watching our blind side. But the clock is ticking. So here's the answer to the question we started with. 1997 NC1 was never the threat. It's been tracked since 1997, 29 years. We knew exactly where it was heading and exactly how far it would miss. The real danger is the estimated 15,000 near-Earth objects, 140 meters or larger, that haven't been found yet. Those are the city killers. And any one of them could arrive the way Chelyabinsk did, from our blind side, without a single day of warning. But here's what makes right now different from every other moment in Earth's 4.5 billion year history. For the first time, a species on this planet can see the rocks coming. And in 2022, that species proved it can push one out of the way. We spotted the asteroid, we built the spacecraft, we changed an orbit. Now, we just have to finish building the net before the next one doesn't miss. The asteroid that grabbed today's headlines was never going to hit us. It passed safely, exactly the way every model predicted. The real question isn't about the rocks we can see, it's about the ones we can't. If this changed how you think about what's flying past your planet, hit subscribe and the bell. Because the next story we're telling, it might be even bigger than a kilometer-wide rock sailing past Earth.